Hello, we're looking to do a two-parter about physical properties of covalent compounds. Let's see what we got. So, physical properties of matter are observed or measured without changing the identity of the matter. We're going to focus on 4 of these. We got boiling point, melting point, solubility, which means something dissolved in a liquid, and electrical conductivity. Boiling point. What is it molecularly? It means this is the temperature which molecules overcome the attractions between intermolecular forces. So essentially when they separate. Now, this depends on what type of intermolecular forces you have. So generally speaking, dispersion forces are the lowest type of attractions. Therefore they have the lowest boiling point. Dipole-dipole is next. Those have medium attractions, while hydrogen bonding has the highest attractions. So why do most nonpolar have low boiling points? Having only dispersion forces mean they have the lowest type of forces, so the lightest attraction. We could see that this grouping of nonpolar covalent compounds in general has lower boiling points as a group than polar covalent. Now, we can see that this does change over time. With polar covalent compounds, they have higher boiling points because they have the dipole-dipole, and they could have the hydrogen bonding forces. So what that means is that they have stronger attractions in general, so they're able to have higher boiling points because they have more attractions. However, there's always exceptions to these trends. So let's take a look at some of these exceptions. So if we have CCl4, it is non-polar. Its boiling point 77. pH3, it is polar, but it's at -88, much lower. And that's because CCl4 has a heavier mass and more electrons, which means it's going to increase its attractive force. I kind of give an analogy thinking about Velcro and regular glue. If you have a little dot of Velcro, it can hold a certain amount of weight before it tears off. Glue, same amount of dot, can hold more weight after it's allowed to dry. But if you have a piece of Velcro the size of the hood of your car, the roof, that can actually lift the entire car. Go ahead on YouTube, take a look at some videos of that. I'm sure you'll find something like I have. While glue is a stronger force by itself, you can have enough Velcro to lift off much more than any amount of glue can. So even though these have more attractive forces in general, these can be heavier and increase the attractive force. CH4, CCl4, replace the light hydrogens with heavier chlorine, and you have a dramatic increase in the boiling point. Let's take a look over at melting points. Alright, let's look at some melting point examples. Now this is very similar to boiling points, to be honest. What does it mean molecularly? This is the temperature at which some intermolecular forces are overcome in a solid, and then it's allowed to move and flow as a liquid. Now the melting points are related to the intermolecular forces. So lower intermolecular force attraction, lower melting point. Medium attractive force, medium melting point. Hydrogen bonding is going to have the highest. Now again, these are as a class. Now nonpolar covalent compounds have lower melting points because they don't have these positives and negatives to attract. So if we see something like methane, nonpolar, it has the lowest on the table. Now this can increase with mass, like we saw with boiling points. This has chlorines replacing hydrogen, so we see its melting point jumps up quite dramatically. Likewise, if we have something like chloroform, we can see it has one less chlorine, and even though it's polar because of that, because we have different atoms around the central atom, that's because one less chlorine, less electrons, so it's a little lower. Hydrogen bonding like acetic acid and ethanol and methanoic acid with these OHs are going to have higher attractive forces than you will see with a smaller methane. So those polar covalent compounds, higher attractive forces, going to have more things that connect it, making it hard to overcome. However, if things are heavier, that can overcome that same trend like we saw with boiling points. Let's jump over to part 2 so we can continue looking at the different physical properties. See you there.